So this is one function eating another function. It's called a composition of functions. Which fish got eaten? Which one got eaten, the F or the G? G was eaten. Do you agree that that means G must have been smaller than F? Yeah, the little fish can't eat the bigger fish. That just physically can't work. But the big fish can eat a little fish. Would you agree that today in the ocean, some fish ate another fish? For sure. Okay. Would you agree that there's a high probability that a medium-sized fish ate a smaller fish, and then a bigger fish ate him? So you could have a fish inside of a fish inside of a fish. Absolutely, probably happened in the ocean today. In fact, I bet you this has happened. I bet you there's 7 fish that are all nested inside of each other, and then that's eaten by a bigger fish. So 8 fish that are all like a fish that ate 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 a fish all today, because the ocean's a big place. That probably happened somewhere. Okay, so this F fish ate the G fish. And now, here's how you do that math-wise. You take the F function, which was the top one there, x squared plus 5x minus 40, x squared plus 5x minus 40. I need to clear up some room for myself here, so let me erase for just a second here, just to make room. Okay. Now I'm going to make an empty spot where those x's are, because the F function has to eat something, the F fish. And what does he eat? He eats the G fish. And the G fish is right there, 2x plus 16. So now we can see that 2x plus 16? Yep, plus 16 is inside. Two x plus 16 is the thing that got eaten. The F fish ate the G fish. And from here, it's really pretty simple. I'm just going to make this a little cleaner. And then there was a minus 40, I think. Was it minus or plus 40? Louder? Minus 40, thank you. Okay. I got to trust that you are able to multiply this all out by now and then put it all together. Do you think honors pre-calc kids can generally do that? Yeah. So I'm trying to teach you the big picture stuff. You need to know how to already multiply this out. And I got to be able to say, you got that. Okay. If you understood what I just did, please take the G function, which is the 2x plus 16, make a spot where the x is, and have the G fish eat the F fish. G of F of x. This is one function eating another function. So, x squared plus 5x minus 40 goes right there. And I got to trust that you can multiply that out. All right, so that's having a function eat another function. That is called a composition of functions. So let's get to the slide. Composition of functions is what we're doing today. Well, composition is kind of like the word composite. Would you agree that those words are similar? A composite is a mix of two things. Like, for example, how many of you at home have a tennis racket? Okay. I bet you anything your tennis racket is not made of just one material. Your tennis racket is probably a composite of 2 different metals. One of the metals is good at being stiff, and another metal is better at being light, and together the composite is a really good combination. Well, composition of functions is 2 functions that are melded together. All right, so this is not super clear on what you're supposed to do. I think this is better. Everybody write G parentheses F parentheses 1. And I'll say it to you. That means G of F of 1. That means that it's like the fish ate the fish ate the fish thing. What did the F function eat? A 1. Everybody go put a 1 into the F function. When you put a 1 in there, Zoe, what do you get? 1 minus negative 4.
5.
Sorry, I put you on the spot. 1 squared minus 4 times 1 is 1 minus 4, which is negative 3. Okay, so negative 3 is what you get here. And then it's g of negative 3 is the next problem. It's like you just keep going from the inside out. Camille, where should I stick the negative 3 now? Yes, here's the g function, and I stick the negative 3 in there. Well, that one worked out pretty nice, because negative 3 plus 3 is 0, right? So it's 2 minus, the square root of 0 is still 0, so 2 minus 0, so it's 2. And that's the answer for the first question. Do you see how I did that? Milan.
Will it be formatted like this?
Yes. Yes, I know those are mildly annoying, but get used to it. F of, everybody finish that one, and actually try it. Make the g function eat the 1, because it's f of g of 1. Try it yourself. You'll learn so much more doing it than just watching me. Pausing while you try that. Is where you'd put 1 into the g function, which was this one. And when the 1 goes there, I have square root of 4. That worked out nice. 2 minus the square root of 4. Square root of 4 is 2. 2 minus 2 is 0. Raise your hand if you knew that this was f of 0. Good. And then when you actually stick 0 in the f function, you get 0 again. Final answer, 0. How many of you had that one right? Okay, cool. Next one, g of 6. Shouldn't need my help. Should be able to just boom. This is no problem. Now this one brings up an interesting point, because at the end of it, you'll have a choice. You can either write the answer with a square root in it, or you can write the answer with a decimal in it. The easier thing is actually the more accurate thing. So when you stick the 6 in here, you get square root of 9, and I hope you don't think that's two things. There's always a few kids that still have that stuck in their head that the square root of 9 is two things. It's not. The square root of 9 is just 3. What they're thinking of is when you have this is different. Then there's two answers, but it's not because there's two square roots of 16. It's because this is the absolute value of x. That's why there's two answers to this. But the square root of 9 here is only one answer, and it's 3. All right. So then I have 2 minus the 3, which makes negative 1. G of negative 1, and what's the final answer? Joe, what'd you get?
2 minus square root 2.
Perfect. And that is called an exact answer, because the square root of 2 goes on forever and never repeats. It's not just like 2.3. It's a number that goes forever. So if you're going to stop and round it to something, it's not going to be as exact. This is considered an exact answer. All right. The next page. This one, I believe it'll confuse you more than help you. So since we're down to under 15 minutes left, I'm going to move on. This one is where we get into the domains of composite functions. So I need to tell you a formula that you need to write down, and you'll have to memorize this formula to be able to have a chance to find the domain of a composite function. First of all, what is a composite function? If I said to make this function eat that function, I think you could do that. You just did that a minute ago. That's called a composite function. But what's its domain? Well, this one has a domain of x is less than 5. And this one has a domain of x is greater than 1. Can I just intersect them? No. Much more complicated than that. So here is the formula. Up above this on the same page, I strongly recommend you write this down so you might remember it. To get the domain of the composite, you start with the domain of the inside one. Like one function has to eat the other one, right? So it's the domain of the inside function intersected with the inside function again. It's weird that it repeats like that, but it does. The inside function in the domain of the outside. You've got to memorize that. Not making this ambiguous. It's very clear. We're not going to give it to you. You have to have that formula memorized to be able to have a chance to do this problem. So watch me use that on this first question. Find the domain of f of g of x. All right, which one's the inside function then? G. Which one's the outside function? F. Okay. So you may recall that I started with the domain of the inside one, which is the domain of G. Intersect that with the inside function, not the domain of it, the inside function, which is g of x. And I don't know what it is yet. Oh, there it is. There's g of x. So x squared minus 4 is the inside function. And that has to be put into, this is me just reading this formula, I got to put it into the domain of the outside function. So how do I put that into the domain of the outside function? Well, first of all, this one's the outside function, f is. And here's the domain of it. And if I want to put x squared minus 4 into this, where do you think I would put it? Milan, where the x is. Yep, so x squared minus 4 is less than 5. Do you see how I took it and put it in that? I put it inside the x is less than 5, and there it is. And now what is the domain of g? I can replace that with the fact. Here it is. It says so. It says x is greater than or equal to 1. So I'm going to erase domain of g and put that. Domain of g is x is greater than or equal to 1. And now that looks like something you could do. A number line with a 1 on it, intersected with another number line. But wait, I got to solve this. Pre-calc. So many steps. Adding 4 to both sides. X squared less than 9. Oh, that's working out nice. Do you get that there's 2 answers for that then? But did you know that it's a less than and a greater than? Let me show you. Absolute value of x, remember that part, is less than 3. Remember how there's only 1 square root of 9. Okay. Now I'm going to split it into 2 parts. Pay attention. If you're not listening, look up now and listen. This is x is less than 3 and x is greater than negative 3. Why? Remember when you do the opposite, you divide everything by like a negative? That makes the sign switch. It's like that. Okay, so now I have to graph that. X is less than 3. Well, here's where 3 is. And x is greater than negative 3. Well, negative 3 would be like way down there. And it's in between those two. And now, I don't know if you remember this from yesterday, we see where they overlap each other. They overlap right in there. Would you agree it's between 1 and 3? Do both of them have 1 in it? So is 1 included, or should I put a parentheses? No, it's a bracket on the 1 to 3. And the 3, one of them isn't 3, so it's a parenthesis. And there's your final answer. Right there. That was difficult, I know, because it is a formula you've never seen before. It involved simplifying inequality that had an absolute value in it. Holy cow. Well, this is pre-calc. You chose honors. Not supposed to be super easy. Okay, yes.
I used the rest, right?
Yes, you may. All right, on to this one. Everybody try one yourself because this is the kind. Before that, though, apparently there's a question. Go ahead.
Could you explain more why the sign flips would be squared?
Yes. It's because of, not because of the square root. Remember when we square root a variable, you get absolute values? It's because this is an absolute value. Would you agree what's in the absolute value could either be positive or it could be negative? Do you remember that?
Negative x, we have to divide it by 1.
It's like dividing by a negative, yes. So then that makes the sign switch around. All right, sure. And the way you can know it, I actually did it right. We figured out the answers are between -3 and 3, right? So try numbers that are between -3 and 3, and you'll see that they work. Like -2, is that less than 3? Yeah, when you absolute evaluate, it works. And anything bigger than 3 is not going to work, like 12. Well, 12 isn't less than 3, so that doesn't work. So you can test and see that way works. But the first one is exactly what you see without the absolute values. The second one is always opposite here, and since it's opposite, sign has to switch. Any other questions? Okay then, try this one. This is hard. I don't expect everybody to get it. Do you remember me telling you that about the careful test? And like only like, I don't know, 8 of you got it right the first time? It's kind of like that. You start with the domain of the inside though. Pause for a second while you try that one. Okay, let's see how you did. The domain of the inside. In this case, the f of x is on the inside. I hope you noticed that. The f of x is on the inside, so it's the domain of f, and that's x is less than 5. Intersected with the inside function, which again is the f function, which is the 5x plus 1. So 5x plus 1 goes into the domain of the outside function. So it's going to get stuck in the x of the outside function, which is the g function. So that's this function. So that goes in where the x was. So that squared minus 4. Nope, I just put it in the wrong thing. Dang it. Sorry. 5x plus 1 goes into the domain of the outside function. The domain is this. Okay, so it goes in and this is greater than or equal to 1. So 5x greater than or equal to, double checking that I'm on the outside function, x is greater than or equal to 1. Yes, the outside function is, okay, I'm doing it right, good. I'm subtracting 1 from both sides, and I get 0. That's a little weird, but I divide by 5 on both sides, and you can take 0 divided by 5. It's just 0. X is greater than or equal to 0. On the other side, x is less than 5. So then I put them together. Here's where 5 is. Here's where 0 is. And where do they overlap? Looks to me like it's in here. Between 0 and 5, and it includes 0 but does not include 5. I feel like I made a mistake there, but I don't think so. Can anybody verify you got the same thing without just copying me? Okay, good. Then I think it's right. 0 to 5. All right. Those are not easy. You have a formula to memorize. You know what would help you memorize it? If you practiced it a couple times. So do some homework. And that's all I have for the video for today.